There's a perfect hole on the surface of the moon. Not a crater. Not the jagged, uneven scar an asteroid leaves behind. This is circular, clean, with vertical walls that drop 90 meters straight down into total darkness. And at the bottom of that pit, NASA's LRO probe picked up something in 2023 that rewrote the agency's engineering plans for the next several decades. There's a cave, not a small pocket. A cavern that extends horizontally from the base of the shaft, with a stable temperature of -20 degrees Celsius, 0 cosmic radiation, 0 micrometeoroids, none of the swings between +120 and -170 degrees that make the lunar surface nearly impossible for humans to survive long-term. And NASA has a plan to live inside it. Here's the thing. This video is going to answer 3 questions that connect the moon's oldest geology to the future of human exploration. How did these tunnels form? And why did lunar gravity make them so massive that nothing like them exists anywhere on Earth? What exactly did the LRO sensors find in 2023 at the bottom of the Mare Tranquillitatis pit? And what makes it unlike anything else on the moon? And the question that defines the entire future of the Artemis missions: when is the first human going to sleep inside the moon? Stay with me, because the answer to that last one is closer than you think. Between 1 and 3 billion years ago, the moon was volcanically active. The dark patches you can see with the naked eye from Earth, the large flat regions that ancient peoples thought were oceans, are actually plains of solidified lava, massive flows of magma that covered impact basins over millions of years. When a lava flow advances across a surface, the outer layer cools and hardens first, forming a crust. But the liquid magma beneath it keeps moving. When the volcano eventually shuts down and the interior lava drains away, what's left is a hollow tube underneath the hardened shell. On Earth, lava tubes exist in Hawaii, Iceland, the Canary Islands. The longest known on Earth, the Kazumura Cave in Hawaii, stretches 65 kilometers. On the moon, lava tubes are on a completely different scale. Lunar gravity is 1.62 meters per second squared, about 1/6 of Earth's. In low gravity, an arched rock structure can support itself with far less material. A model from Purdue University published in 2020 calculated that on the moon, a lava tube could maintain structural integrity with a diameter of up to 1 kilometer, without collapsing. On Earth, that same tube would cave in under its own weight over geological time. 1 kilometer across, several kilometers long. An entire city could fit inside. And that's not speculation. The evidence is real. In 2009, the LRO probe photographed the lunar pits for the first time, the collapse holes where the ceiling of a lava tube gave way and left a circular entrance into the interior. The pit in Mare Tranquillitatis is 100 meters wide. The Marius Hills pit is around 65 meters. The Mare Ingini pit is 120 meters across, with vertical walls that drop more than 100 meters to the floor. In 2017, the Japanese probe Selene, known as Kaguya, aimed its radar at the Marius Hills region and found something the pits had implied, but nobody had been able to confirm directly. The radar penetrated the surface and detected a subsurface chamber at least 50 kilometers long and roughly 100 meters wide beneath the pit zone. The first direct evidence of an intact large-scale lunar lava tube. But the most important data came 6 years later, and it shifted the conversation from "this might be possible" to "this already exists and it's accessible." The real problem was never whether the tubes existed, it was confirming you could actually get inside one. For years, the existence of lunar lava tubes was considered probable, but unverified in detail. Scientists knew the pits were potential entrances. Nobody knew what was at the bottom, or whether the space was large enough and accessible enough to be useful. In July 2023, an international team led by Lorenzo Bruzzoni of the University of Trento published results in Nature Astronomy from an analysis of data from the LRO's Mini-RF instrument, a synthetic aperture radar designed to penetrate the lunar surface several meters deep. The data pointed at the Mare Tranquillitatis pit showed an unmistakable radar signature. At the base of the shaft, 90 meters down, the radar detected a cavern extending horizontally. The signal showed the space is at least several tens of meters wide. The full extent can't be mapped from orbit. The radar could only see the entrance from its observation angle. But what that data confirmed is concrete. There is a cave accessible from the bottom of a 100-meter pit on the moon. Not hypothetical. Radar confirmed. Published in Nature Astronomy. Get this. The temperature the LRO's thermal sensors measured inside that cavern was -20 degrees Celsius. Constant. While the surface of Mare Tranquillitatis hits positive 120 degrees in full sunlight and drops to -170 during the lunar night, the interior of the cavern holds steady at -20. A thermal swing of 290 degrees on the surface. Essentially zero swing inside. That's not just a geological data point, that's the most thermally stable environment anywhere on the moon. And it changes the entire engineering math for a lunar base. The lunar surface has 3 problems that make long-term human presence nearly impossible without massive protection. The first is radiation. With no atmosphere and no magnetic field, the surface receives the full dose of galactic cosmic rays, solar energetic particles, and ultraviolet radiation. A year-long mission on the lunar surface would accumulate a radiation dose equivalent to more than 1,000 transatlantic flights. Just 1.5 meters of regolith overhead brings that exposure down to levels comparable to Earth's surface. Lava tubes have between 5 and 20 meters of solid rock ceiling. The radiation inside is essentially the same as standing on Earth. The second problem is micrometeoroids. No atmosphere means every particle, from cosmic dust to centimeter-sized fragments, hits the surface without friction. The impact rate is continuous. Any structure on the surface needs constant physical shielding. Inside a lava tube, 0 micrometeoroids. The third problem is temperature. Engineering thermal control systems for an environment that swings 290 degrees over 14 Earth days is an extreme design challenge. Inside the tube, that problem disappears entirely. NASA and ESA have active programs evaluating lunar lava tubes as habitation infrastructure. The general concept: robots arrive ahead of the humans, seal off sections of the tube with inflatable structures, 3D print additional shielding mass using regolith, install power generation systems connected by cable to solar panels on the surface, and pressurize the interior volume. Humans arrive to an environment that's already prepared, without having to build from scratch on the most hostile surface in the accessible inner solar system. The Mare Tranquillitatis pit sits at 3 degrees north latitude, far from the South Pole where Artemis IV plans to land. But there are pits in other regions currently being evaluated, and the 2023 confirmation that the Tranquillitatis pit has an accessible cave at its base has dramatically increased interest in polar and subpolar pits as base candidates for longer missions. There's a detail buried in the 2023 data that NASA's official communications mention briefly, but that engineers are studying very carefully. The mini-RF radar detected, in addition to the main confirmed cave at the base of the pit, a secondary signature at greater depth and horizontal distance. That suggests the confirmed cave could be just the visible entrance to a much more extensive underground network. Lava tube architecture on Earth frequently shows branching and multiple levels when formed by complex flows. If the system under Mare Tranquillitatis follows that pattern, the confirmed cave could be the doorway to a habitable volume far larger than what's been mapped. That can't be verified from orbit. It requires descending to the base of the pit with physical instruments, which requires a mission specifically designed for that objective, or astronauts. No robotic mission has done that yet. The pit walls are vertical. Descent requires a rappelling system, or a specialized lander built for tight enclosed entry, none of which currently exist in any agency's near-term manifest. But the confirmed cave at the bottom means the engineering question has shifted from, is there something worth going to, how do we get down there? That's a meaningful change, one that tends to produce missions. Straight up, everything this video has covered converges on a single image that science fiction anticipated, and that engineering is now turning into an actual plan. A lunar base is not going to look like a capsule module sitting on the surface. It's going to be underground, literally. Inside a volcanic rock cave formed 1 billion years ago, sealed and pressurized, thermally stable, radiation-free, impact-free. The most Earth-like environment anywhere on the moon wasn't built by anyone. It was waiting, intact, since the moon stopped being volcanically active. Lava tubes aren't an alternative plan for lunar surface bases. For longer missions, the ones that need weeks or months instead of days, they're the only plan that engineers can model with numbers that actually work. The question I keep coming back to: if the first accessible cave system is confirmed and the habitation blueprints already exist, when is the first human actually going to sleep inside the moon? And what are they going to find when they explore deeper than the radar could ever see? Drop what you think below. And if this video changed how you imagine the future on the moon, subscribe. Next week, the South Pole water that would make living inside those tunnels permanently possible.